The lesson outcome for this video is, I can solve quadratics in vertex form. Okay, so first of all, let's remember that standard form is what we've been working with in our quadratics so far. So y equals ax squared plus bx plus c. We've been using this form for both factoring and for using the quadratic formula. So now, what is vertex form? Well, vertex form is still going to be y equals, and we're still going to have an a value, but then things get a little different. We have parentheses, and inside the parentheses we have x minus h, close the parentheses, and then square it, and then plus k. So obviously this looks a lot different. And the main thing to notice is that instead of having an x squared term and an x term and a constant term, what we have is a situation with parentheses that are being squared. Okay, so when you see those parentheses, that is a giveaway that we have vertex form. So for this equation that's in this same form, notice that the y is here. That means a is 3, right? So a is 3. Put that right there. And then we have our parenthesis and our x, and then this minus sign, which means that h is 2. And then we have our closed parenthesis squared, and then we have plus k. Now if it's plus k, but this is minus 6, that means k is negative 6. And we'll talk way more about those different parts of this equation later on in this unit. But for now, what we're going to work on is how would we solve this equation right here to find our x-intercepts, just like we were working on in the previous units. So let's try some of those. This example asks us to solve the equation to find the x-intercepts. And again, as we've been doing in other units, remember that to find the x-intercepts means to find the value of x when y is what? Again, think about a coordinate plane. Think about when it's an x-intercept, like this point right here would be an x-intercept. What is the y value there? And the y value is 0. So we need to solve this equation right here when y equals 0. So let's put a 0 in for y and solve. I'm just going to rewrite the whole equation. And then how would we go about solving this equation for x? Again, we're trying to get x alone, and it's got all this stuff with it. Well, we're going to solve this by using the order of operations in reverse. We are going to do what's called solving by undoing PEMDAS. So we're going to start by adding or subtracting anything that's over here on this side of the equation that we don't want there anymore. So let's add, we have to do the opposite. So we're going to add 27 to this side of the equation. Now if we do that, remember we need to also add 27 to the other side of the equal sign. 0 plus 27 is 27, and our equal sign is still there, and the 3 is still there, as is our x plus, 2 squared. After adding or subtracting, we now need to multiply or divide. So this whole thing here in the parentheses, even though it's being squared, we need to deal with the 3 first, because that's being multiplied. So we're going to divide this side by 3, which means we need to divide this side by 3. 27 divided by 3 is 9. The 3's here will cancel and make 1 over 1. And now we have x plus 2 squared. Now, the exponent is our our next thing to deal with in this equation. This exponent is saying that this is squared. So what you need to do is you need to undo the square. And how do we undo a square? Well, we square root. So we're going to square root this side, and we're going to therefore need to square root that side. What happens over on this side here is that the square root and the square cancel each other out, and we've got x plus 2. And by the way, we don't need the parentheses anymore, so we have x plus 2 equals the square root of 9. And the square root of 9 is 3, because 3 times 3 is 9. But we have to remember that there's actually one more answer. And what I mean by that is if you think, let's go over here for a minute, if you think about the question, what number when multiplied by itself equals 9, most of us would say 3. But there's another option, and that is negative 3. Because if we square negative 3 times negative 3 is positive 9. So anytime you square root both sides of an equation, you need to include a plus or minus sign. And we saw the plus or minus sign when we did the quadratic formula, so you should be kind of used to seeing it and using it. So now we're going to go one more step here, and we are going to say to get x alone, we still need to subtract 2 from this side to cancel these, and we need to subtract 2 from the other side of the equal sign as well. Now what that will do is actually give us, again, two different situations here. A positive 3 minus 2 and a negative 3 minus 2. So I'm going to go ahead and write these down. Whoops, I didn't mean to. Let's see. What I'm going to do is I'm going to write these down over here. We have x will end up equaling, and I am switching around where the x is. The x is on the right-hand side of the equal sign right now. I can move it over to the left-hand side. That's fine. So x equals positive 3 minus 2, or x equals negative 3 minus 2. Now the minus 2 is minus 2 in both of them, right? But the plus or minus 3 means I have the plus 3, the positive 3 here, and the minus 3 or negative 3 here. So x equals positive 3 minus 2 is 1, and x equals negative 3 minus 2, which is negative 5. So there are two answers, just like we got when we used the quadratic formula to solve quadratics. And again, not always, but a lot of times we will get two solutions. Okay, let's try just one more example so that you can see the whole thing run through again, and then we'll of course do practice in class. Okay, so to solve the equation, to find the x-intercepts means we're going to start by putting in a y value of 0 so we can find out what x equals, right? So we're going to go ahead and put a 0 in for y. If you feel comfortable and confident at this point trying an example on your own already, go ahead and do that. But if you'd like to just watch this one and follow along with me and put it in your notes, that's fine as well. So I'm going to write the PEMDAS acronym again over here and remind you that we need to do the reverse of PEMDAS because we are doing solving by undoing. Okay, solving by undoing the PEMDAS steps. And we're also undoing the operation. So it's kind of undoing in two different ways. So again, we're going to start by adding or subtracting. We can't do what's in the parentheses yet. We can't do this multiplication yet. We have to do this addition right here. So I'm going to undo the addition using subtraction. I'm going to subtract 64 from both sides of the equal sign. 0 minus 64 is negative 64. And that will equal negative 4 times x plus 2 squared, and these will cancel each other out. Now we will multiply or divide. We have multiplication here, right in between here is multiplication, so we need to divide both sides by negative 4 in order to get rid of that negative 4. So when we cancel that out, negative 4 divided by negative 4 ends up being 1 over 1. Now, negative 64 divided by 4 is 16, and it's negative divided by a negative, so the answer is positive 16. And now we have x plus 2 squared. Next, to solve and try to get x alone, we need to deal with our exponent. It is being squared, so we need to undo that by square rooting. The square root of 16, again, when we square root both sides, we need to put a positive or negative 4 here. Positive or negative 4. Again, the square root of 16 is 4 because 4 times 4 is 16, and then we have to put the plus or minus. The square root here cancels with the square right here, and we're left with x plus 2. So the last thing we're actually dealing with here, and I think I didn't explain this on the previous slide, but the last thing we're dealing with is the parentheses. Those parentheses we're dealing with last, way up here. Those are the last thing we'll deal with. They aren't needed here anymore because we just have x plus 2. So now subtract 2 from that side, subtract 2 from this side. The positive 2 and the negative 2 will cancel off on the right. And now right here is where we have, again, two different things that can happen. So I will typically write them, I will put the x first and say x equals that positive 4 minus 2. And the other option is x equals negative 4 minus 2. Okay, the positive or negative 4, there's the positive 4, there's the negative 4. All right, so x equals positive 4 minus 2, well, that will be 2, and x equals negative 4 minus 2, which is negative 6. Here's our two solutions.